at one of the four what's called conic sections of, it's called circles, which you've already done this in geometry probably before, so a lot of this is going to be a review. But at the very end of this lesson, you're going to see things that are going to be new. Okay, but first, just a review. So first of all, what is a circle? It's actually kind of a non-intuitive definition. So a circle, as it says right here, is the set of all points equidistant from a point called the center. So really, there's the center. We call that HK, just to not confuse it with points that are actually on the circle, which we call XY, right? And a circle is actually a bunch of points that are all the same distance, the length of the radius, all the way around. Like if you just take every infinite point that's the same distance from the center, eventually it turns into a circle. So we look at circles, as drawing a nice smooth curve, whereas geometrically speaking, it's actually a bunch of infinite number of dots all connected that make up a circle. Kind of interesting definition, right? And it's very close to, I'll put HK here and XY here. Yes. All right. So that's where that comes from. And you can derive it from the distance formula, because after all, if I want to find how far it is from here to here, that's really a Pythagorean theorem question. Right? If I ever want to find a diagonal distance, that's really a Pythagorean theorem. You find the rise, you find the run, do a squared plus b squared equals c squared, right? We just call everything a little bit different, right? So instead of the distance, we call it r. Right? So the distance becomes r. And the distance, it says x2 and x1. We don't have x2, x1. We have blue. We have x and h, right? So in the formula, it just says x minus h. It means the same thing. They're just called different things. And then we have the y values, right, which are y and k. Yes. Okay. And instead of having the square root, we actually leave it as r squared. So in a sense, it does look like a Pythagorean theorem. It looks like c squared equals a squared plus b squared. Right, but this is known as the standard form of a circle. Now, anytime you hear standard form for this month, know that is the same as the graphing form. So if you want to graph it, you want to put it in called standard form. And there is another form called general form, which just has everything all multiplied out and looks like a long polynomial. Okay, but usually we're concerned about getting it into standard form and finding out what the center and the radius is and everything. So just to review, for a circle, right, you just need two things. One way or another, you need, number one, you need the center, called HK, and you need a radius. And then you can find the equation of any circle. Radius. Okay. So as you're looking for any equations, just ask yourself, what do you have and what do you need, right? It will involve those two things. And sometimes you have to be a little creative to find out what the radius is. Sometimes they'll give you like 2 points on the diameter. Like they might give you a point like here and here and say, what's the radius? Right? Well, you'd have to find out the length of the diameter, cut it in half, right? Or to find the center, you'd have to use the midpoint formula. So you're going to use all those formulas we practiced before break to figure out some of these answers. Some of them are more straightforward. Some of them you have to actually sketch out and think about for a little bit. Okay. Some ask about, well, this circle goes through this point and is tangent to the x-axis. So just a reminder, tangent. They're not talking about the trig tangent. We're talking about the geometric tangent. Tangent means to touch but not go through it, right? So if I want to be a circle, if I want a circle to be tangent to the x-axis, right, it would look like this. It would touch the x-axis but not go through it. So that's what tangent means. So you'll have to use a lot of different definitions to find out different equations of circles. Okay? So let's practice the basics back from geometry of just finding like the equation of the circle and whatnot. Let's do that first. So remember two things. Center. What are the coordinates? Start there. So here we got a coordinate of 3, 3. And then what is the radius? Identify that. And you may probably not have to write this out. I'm just being thorough. Right? And that's 2. And then you can write the equation of that circle, right? Using that standard form. And it always starts with the same thing as this Pythagorean theorem looking, distance formula looking thing. Right? So this is going to be the same on all of them. And you just have to put in the numbers for the center and the radius. So 3, 3. Right? Radius is 2. And that's about it. Generally, we do simplify, 2 squared. Instead of writing 2 squared, we would put 4. You just have to be careful looking at 4, knowing that's not the radius. Right? 4 is not the radius. It's the 2. So if you have just a number here without this square, you have to take the square root of it, and that will give you the radius. Okay. All right. So sometimes they give you this. You have to, get it by looking at the graph. Sometimes they'll just give you the information, no graph, right? So you can do it either way. So we have here we got x minus 2 squared plus y. Okay. Something like that. All right. But what are the mistakes that you see? What's that? Plus 2, because this is a minus. Minus a negative. What's the other one? No square on the y. So these are going to be the most common mistakes. It's going to be something like this. Oh, it's supposed to be a plus instead of a minus. Oh, I just forgot to put that there. Or they'll say the radius is 4 instead of the square root of this number, right? So the difficulty here is not going to be the big picture. Did you get the graph right? It's going to be more of that kind of stuff. So once again, how neat you write and how big you write is going to avoid those types of mistakes. Can't say it enough. It's a common theme in math that people writing small, they just miss more problems, period, right? People writing not enough steps, miss more problems, period. So if you write more things, write bigger, write neater, you'll make fewer mistakes, period. All right, try the 2 to the right, try B and D, and check someone next to you, see how it goes. So pop quiz for A, what is the radius? What is the radius for A? And you say 3, because you can rewrite that as 3 squared, so that's going to be 3. Right? What is the radius for B? 2, right? So it's not 9 and it's not 4. It just put this here separately because it actually is missed very often. Right? Now, if it was like 13, you could say the radius is root 13. That's fine too. It's okay to have a radical as a radius. Okay. All right, go ahead and finish the rest of those 2. All right, just find the center and go ahead and graph it and check if you need to. Again, this is all review. All review from geometry. Lastly, here's where the honors math analysis part shows up. These are the problems that are going to be a little more challenging, such as we have a circle with a C that is -2, 6 containing a point 1, 4. It doesn't tell you right out, here's the center, here's the radius, and just do it, right? So, and this is where you can see, well, it has this point and it's tangent to the x-axis, right? And you have to use some of those other definitions. So, a few words of advice on these. Start off with the equation, right? And so this is going to be the x minus, just, and see what you can fill in. Sometimes you can fill in quite a bit and get most of the answer just by what's given. Right, so, and little details that you wouldn't know unless I told you is that if it says C, that is automatically the center. So it's not like if it A, B, D are all the same. If it says C, that means this is the H and this is the K. So you already have the +2 and the -6 part. So you have a big chunk of the answer already, the equation we're looking for, but we are missing the radius. So by putting in here what you have, you'll know what you're missing and say, okay, with the information I have here, I need to find the radius. How do I find the radius? And recall from the very beginning, the radius is just a distance, right? It's a diagonal distance. So you're probably going to use the distance formula. Right? And you can connect these together and you just figure out, okay, so this one's the center, right? And this is somewhere on the circle. If I know the distance between the center and some point on the circle, that's what's called the radius. Same thing. So we can use the distance formula here. Right? But you have to logically reason out why you're doing what you're doing to make sense out of all of it. So we have distance from -2 to 1, looks like. Those are the x's. And then you're going to add distance from 6 to 4, which is going to be 2. So that's going to equal 3 squared plus 2 squared, which equals root 13 squared. Oh no, root 13. Yeah. And some of these you're going to want to solve graphically. If you can't figure out equation what it's saying, like possibly the one with the tangent, graph it first and see what it looks like, and you might be able to figure out, oh, the center is this because of this and this, and because you're looking at it. So most of the time you can approach it, analytically with formulas and equations, but sometimes it's just that doesn't work. Graph it. You're like, I don't know what that means. Graph it, and then you can see if you can figure out what the center or the radius is by graphing it. And you won't have any, formulas to get you there, but the graph alone will help you solve it. Okay, so what should I put right here? What should go right there? 13. Ooh, pink 13. Pink 13. All right, 13. Because it's the radius squared, so it's, right, root 13 squared. That's why this is 13. Okay. All right, and now we get to graph it. So yes, you can have a radius. That's a radical. You will need a calculator to help you approximate it. It's between root 9 and root 16, so you know it's between 3 and 4, somewhere in the middle. Let's call it about 3.5-ish. All right, somewhere right in the middle, more than likely. I just estimated. I could use a calculator, but we're graphing it. So 3.4 or 3.5 or 3.6 as I'm graphing is really all going to look the same. So I'm not too worried about having this perfect, but you could use a calculator to make it more exact. Let's see here. Center is at -2, 6. So I'll go, make this bigger. So -2, 6. Right here. Left 2, up 1, 2, 3, 4, 5, 6. There. And then from there, I'm going to go up 3.5 each direction. Up 2, 3.5. 1, 2, 3. 1, 2, 3.5. Now, if you're feeling like I want this to be, if as you're drawing this, you're like, oh, is it like this? Or is it, am I doing this? You might get a funky looking circle. If you want to get a little more refined, what you can do is find the diagonal distance, the distance you go in each diagonal. And the way you do that is that you just divide the number by root 2. So if I took root 13, you don't have to do this, it's just a way of being more accurate. If I took root 13 here, and then divided that by root 2, I'll get something. Oh, I get 2.5. Yeah, there it is. Get 2.5. And that's the distance you would travel diagonally. You can go 1, 2.5, and then go 1, 2.5, 1, 2.5, and then 1, 2.5. And you can see now it's a little bit easier to draw a realistic looking circle freehand like this way. Now, if you just have a compass, you can skip that and just use a compass. But if you go through all the effort to make your equations and everything correct, you want to have a graph that's also done correctly. There's sometimes a tendency to say, well, I got the right number, the graph is not as important, let's just do that sloppy and ugly. But you already put all the work into doing the numbers correctly. Might as well make the graph as correct as possible. Okay, so a little trick right here. Find the diagonal length, divide by root 2. Right, just makes your graphing a little bit more accurate. All right, lastly, here's where the fun starts, and this is what you're going to be doing a lot on a lot of problems throughout this month. Right, so it's in something called general form. This is the general form where it's just one long polynomial. Right, so we want to convert this. You know, if you see a graph there, that means we need to convert it to standard form. So the question becomes, how do we get it to the form we've been working with all day? You know, how do we get it to this format right here? So this a squared plus b squared equals c squared, you know, type of thing. Well, we need the squares, right? We need perfect squares. This stands for x plus 4 times x plus 4, a perfect square. Same thing, y minus 1 times y minus 1. You know, we got a perfect square. How do you create perfect squares when you don't have any perfect squares? You complete the square. So on each of these, for the x's, right, we have to go through, and it's a good idea to rewrite these with them grouped together. You rewrite them, and you leave a little space to complete the square, right? So this is what we did right before break. So the idea is, what number, if you put in here, it'll factor to something that is the same thing, right? Same factor twice. Then, of course, we have to do it for the y's. So we have to do the same thing over here and do that for the y variables. So you have to do completing the square twice per problem sometimes. And set it up that way. And this is where a lot of mistakes start happening by kind of not really doing this groundwork. It's very tempting to want to just start solving it right away and not write things out the way I'm showing you. But I promise you, if you kind of set up every problem this way, you'll more or less get it right every time, because it's, you know, it's got a structure to it. Whereas if you just rush through it, it could go wrong. Now, on the left-hand side of the standard form, it's only x's and y's, right? But there is a number on the other side that becomes a radius. So any number without a variable, you want to move that over. That's going to help you become the radius. So we'll put that over there. So this is what you want it to look like before you start filling in any numbers or anything like that. Right? Just write it out this way, and that way you will avoid a lot of mistakes. Let's see here. Okay, so first, here's how we go through it. You need to complete the square. The way we did that is we took half, as always half, of this value, right? B. Half is 6 in this case. Yep. Oh, no. So then, what we do is take half of that number, whatever it is, and that goes right here. So that's going to be 3. Okay. So first do this, then we're going to put that number there, and then we're actually going to square it, and you're going to get 9. And we have to add that to the other side, because this is an equation now. So I also have to add it to the right-hand side. So there's 4 steps each time you complete the square. First, take half, fill in down here, right, in the actual, you know, completed square. We kind of go out of order here. Then go ahead and square it up here to get the 9, and that's how you know what to add to the other side as well. All right, so try that on the second part here. Let's see here. So I'm going to do... Okay. Good. And lastly, we can add all those numbers together on the right hand side, and that is going to be your r squared, 36. So there is your standard form, general to standard form. Okay. And then of course you can go through and graph it and get everything you need to down here. But this is what you're going to be doing an awful lot. Sometimes these numbers, this is an easy one, simply because these values, 6, right, and -8 are both even. So when you take half of them, you get a nice even number. But if this happens to be 5, you'll get 5 over 2. This would be 5 over 2. And then when you square it, you'll get 25 over 4. So it's very possible to have a lot of fractions here. You can use your calculator to help you do the arithmetic, but you still want to write everything out. So you might be looking at this like, I don't need to write all this stuff. You know, I could do it. Yeah, wait. You just wait. And then if you start putting coefficients in front that you have to factor out ahead of time when you're doing some of the other shapes, yeah, this is not going to be something, I'm going to learn how to do this fast and not write anything down and I'm going to feel good about it. No. Slow down. Do these slowly with these easier numbers today because they only get more difficult. And the rushing through it, honestly, is what causes the most problems. It's not the math. It's just basic arithmetic, right? It's just take half a number, square that number, add that number, right? It's basic arithmetic, but it can still lead to disaster if it's rushed through, okay? So go ahead and graph that. And where are we at? We're at -3, comma +4, and the radius is 6. So -3, 4. I better get a different one. There we go. Go 6 in every direction. And if I want to take 6 and divide by √2, let's see, 6 divided by √2 is 4.2. So 4 and change. So I can go 4.2, 1, 2, 3, 4, and a little bit. 1, 2, 3, 4, a little bit. 1, 2, 3, 4, a little bit. 1, 2, 3, 4, a little bit. Then I can go ahead and graph it. Good to have you back.